model. So far we've discussed that the spot price is 80 and it can either go up to 110 or it can come down to 60, right? We've already discussed this. And the return of the up move is 1.375 and the return of the down move is 0.75. But now we are adding one new point, which is the exercise price. Now the exercise price is different from the spot price. The spot price is what it is right now, but this is a call option with an exercise price of 100, which means if it goes to 110 and you can buy it at 100, which is your S minus X, what it will be worth is $10. So in the case of an up move, your call option value becomes worth $10 in terms of its exercise value. In case of a down move, if it goes to 60 and you can buy at 100, so naturally you are not going to exercise this, right? And since the value of a call option is maximum of 0 or S minus X, and S minus X in this scenario will be negative, therefore it will not be exercised and the value of this call option will be 0. So in the case of an up move, the call option value is going to be $10, and in the case of a down move, the call option value will be $0. And that is what you can see over here, that the call option value if it goes up and the call option value if it comes down. So if it goes up, it will be 10, and if it comes down, it will be 0, right? 110 minus 100, which gives you 10, and 60 minus 100 gives you a negative value, therefore it will be 0. Now, what do we do with these call option values in terms of pricing the call option today? Because what we are interested in is the value of the call option today, not in the future. In the future it might go to 10, it might go to 0, but what is the value of this call option today? Now, to be able to do that, we're going to use the concepts of arbitrage and replication. And you might remember that we talked about arbitrage and replication concepts for options in the previous learning module, where we told you that this is a dynamic process, because how many shares you want to buy or sell, depending if it's a call option or a put option, depends on this hedge ratio, which is dynamically calculated. And practically speaking, it is done through the Black-Scholes and Merton model, but it can also be done through the binomial model, which is a simpler version of doing it. And this is something we are going to learn today, that how do you use the binomial model to do the arbitrage and replication and use that to price a European call option. So what we basically do is, let's say you are a financial institution and you are a market maker of options, which means you are selling or writing or shorting options, or let's say specifically call options, which means you will receive the premium. Now, financial institutions do this. They sell options and they receive the premium for those options. But how do they protect themselves? Because in case if the stock price goes up, they will lose a lot of money, because the call option, whoever has bought the call option will come and ask and execute the right to buy. Let's say we are talking about Apple shares, and we are giving the right to buy at 80. And in case if it goes to 110, then obviously everybody will come and say, please give us the shares at 80, right? So we will have a loss. So what we do is we actually buy the shares as well ourselves. We buy the shares. So for example, if we've sold a call option for 100 shares that you can come and buy 100 shares of Apple from us, we don't buy 100 shares, we buy a little bit less than 100. And how much less than 100 is something which is called the hedge ratio, which is supposed to be dynamically calculated. And now we will learn today how that H amount is calculated. So how this happens is that you will take the spot price and you will multiply it with this ratio, which is the hedge ratio, that how many shares you want to buy, and this is the amount of money you will pay. So let's say the spot price is 80 right now and we're only buying 50% of the shares. So this is the money we will pay, and the money we will receive is the call option premium which the other party will pay to us, right? Because we're selling that. So our total investment today, which is the value of our investment today, is basically 80 multiplied by 0.5, because we're not buying all the shares, we're only buying half the number of shares, and minus the money we will receive from the call option premium. So this is the value of our investment today. But what we will do is we are first going to calculate the value of our investment in the case of an up move, and we will calculate the value of our investment in the case of a down move. So let's say if the up move is there, then the $80 stock that we had bought, let's say it becomes 110. And we didn't buy all, we only bought half. So 110 multiplied by 0.5 and minus the call option value. So naturally the call option will go up in value as well. So whatever the call option value becomes, let's say it becomes 100 and just 10 because the exercise price is 100, right, as discussed. So this call option value will become 10. And in case of a down move, our stock will go to 60. So we'll lose money over here and the call option will be worth 0. So this is in the case of a down move, this is in the case of an up move. And what we are interested in finding out is what will be the value today. And why we are interested in finding out the value today is because what we do is that this equation, which is the value today, is equal to the spot price today multiplied by the hedge ratio minus the call option value today. So if we can somehow find out the value today, then we can solve for the call option value. And that is how the pricing of the call option is done, that this is what we need to find out. We know the spot price, we figure out the hedge ratio, which is something I will teach you next, that how we figure out the hedge ratio, and then we figure out the value today, and then we plug that value in, we plug this value in, we plug this value in, and we calculate the value of the call option today, because this whole exercise is being done to price a European call option. And how we figure out the value today is by making the value of tomorrow, whether it is up or down, equal to each other. And that is how we figure out the value and the hedge ratio. And let me demonstrate how all this is done. Now, the first thing is that the value today is the hedge ratio multiplied by the spot price today minus the call option premium today. The value tomorrow in case of an up move will be the hedge ratio multiplied by the spot price if it goes up minus the call option value if it goes up. The value tomorrow if it goes down will be the hedge ratio multiplied by the spot price if it goes down minus the call option value. So the value tomorrow if it goes down will be, and let's assume the hedge ratio is 0.5, spot price going down will be 60. And call option value will be 0. Value in case of an up move will be 0.5 into 110 minus 10. And value today will be the hedge ratio into the spot price of today minus the call option value today. So if we can somehow figure out the value of today, then we can solve for the call option value today, right? Which is the objective, that we are trying to price a European call option. We need to find out the value of this call option today. But we have two unknown variables in this equation, which is the value of our investment today and the value of this call option today. So somehow if we can figure out what is the value of our investment today, then we can solve for the value of the call option. And in order to solve for the value of our investment today, we are going to use these two equations, which is the value if it goes up and the value if it comes down, and we will make them equal to each other. So we will make these two equations equal to each other so that the portfolio payoff in both up and down scenarios is equal. And let me just take you to the previous slide for one moment and show you that V up is equal to H into the spot price in case of up minus the call option value if it is going up, and V down is H into spot price of down minus the call option value of down. And we're going to make these two parts of the equation equal each other. And now let me take you back again to the next slide, and that is what you see over here, that they have made HS up minus C up is equal to HS down minus C down. And then they solve for H by making H the subject of the equation. So what they have done is, first they are taking this to the other side. So HS up, and they are bringing this to this side. So this I will bring to this side, and I'll say HS down is equal to C up minus C down. And then I'll take H out, and it will be H outside the brackets, and then S up minus S down is equal to C up minus C down. And then I'll just take this on the other side, and I will say H is equal to C up minus C down divided by S up minus S down. And this is how the hedge ratio is calculated. And this is a very simple way of calculating the hedge ratio. In level 2, you're going to learn how to calculate this using the Black-Scholes-Merton model using delta, and that process is called delta hedging. It will be fun, and I hope to teach that to you in level 2. But for the time being, all you need to know is that this is how the hedge ratio is calculated, where you take the call option value in case of up. So you might remember that that was $10, because when the price was going up to 110 and you were buying, you had the right to buy at 100. So your call option was becoming worth $10 in case when it was going up. And in case when it was going down to 60, your call option was expiring out of the money, so it was worth nothing. And the stock price when it was going up was 110. Sorry, that's 110, not. And if it was coming down, it was 60. And this is how you will calculate the hedge ratio, which will be 10 over this is 50, and that comes to 0.2, and this will be your hedge ratio. Now what do we do with this hedge ratio? The whole point is to calculate the value today, so that then we can calculate the call option value today. And that is what is being done over here, is that first we calculate the hedge ratio, and then we calculate the value when it is up and the value when it is down. And because we have made them equal to each other in both scenarios, we are getting an equal value. So now that we plug in this hedge ratio over here, that we take the spot price when it is up and multiply with the hedge ratio, and we take the spot price when it is down and we multiply with the hedge ratio, and the call option value when it is up and the call option value when it is down, and the value if it goes up and the value if it comes down is the same, because we made it so, right? We made them equal each other, and then we calculated the H value for a point where both value up and value down will be the same. And then what you can do is you can calculate the value today. So you know the value up, you know the value of your investment if it will be down, and we need to know what is the value today. So it's 12 for up, 12 for down, but value today is one period before, right? So you just need to discount it back to today. And that is what is being done in the next slide, that this value tomorrow, whether up or down, you just discount it back one period and you get the value today. So whether up or down, the value is 12. The risk-free rate is 5%. So you divide it by 1.05 and you get to 11.4. Now this is almost done. Now we know the value today, but what we need to know is the call option value today. So again, the value today is equal to the hedge ratio multiplied by the spot price today minus the call option value today. And we need to know this. Now we know the value today, which is 11.42. We know the hedge ratio, which is 0.2. We know the spot price today, which is $80. And now we can solve for the call option value today. So the call option value today is going to be 11.42 minus, it will be, if we bring this to this side, it will be call option value today will be 0.2 into 80 minus 11.42, right? And that is what you see over here, 0.2 into 80 minus 11.42, and it comes to 4.58, which is the value of the call option. Now I know you might be feeling that it's a bit tricky. It's just a relatively long process because there are a number of steps, right? And I've got an example over here, and I'm going to show you the solution step by step, so you are able to slowly understand and digest this whole process. It's not complicated, it is just a long process because there are multiple steps, right? So we'll take it one step at a time. Now the spot price is 50, the exercise price is 55, right? Either it can go up 20% or it can come down 20%, and the risk-free rate is 5%. And what we need to calculate is the option value. Now let's do it step by step. Point number one, if it is having a spot price of 50 and it can go up 20% and come down 20%, then what are the prices it can go to? It can come up 20%, which means multiply the spot price of 50 by 1.2 and you get 60. So it can either go up to 60 or it can come down to 40, which is come down 20%. So 0.8 into 50 will be 40. Now this is the first step, that you calculate what S up will be and what S down will be. This is the first step. Second step is calculate the value of the call option if it goes up. So if it goes up to 60 and your exercise price is 55, then you can buy at 55 and sell at 60. So the up value of the call option is 5. If it goes down to 40, naturally it will expire out of the money. You are not going to buy at 55 and sell at 40, so it will be expiring at 0. So the C down is going to be 0 and C up is going to be 5. So this is the second step. Now we know S0, S up, S down, C up and C down. Next, we're going to calculate the hedge ratio, because the hedge ratio you can calculate since you know C up and C down and S up and S down. It's a very simple formula. You put the C up minus C down and you put the S up minus S down and you get the hedge ratio as 0.25. Now next we need to calculate the value today, and then based on that we're going to calculate the option value. So first, to calculate the value today, we either need to calculate the value of up or the value of down and then discount it back, right? So you can either calculate the value of up or the value of down. They will both be the same because this hedge ratio is calculated by making the value of up equal to the value of down, right? So in this example, we've calculated the value of up, which is if it goes up, it will go up to 60 multiplied by the hedge ratio of 0.25 minus the value of the option if it goes up, which is C up is 5 and the value of up is 10. And you can even calculate the value of down and it will also be equal to 10 for sure. Now we will discount this 10 back to today to calculate the R investment, the financial institution's investment today, which is going to be discounted back one period at the risk-free rate, which is 5%, and you get 9.52. Now you know V0, you know the hedge ratio, you know the spot price today, right? And you can solve for the call option value today, which is the last step. So now you know V0, which is 9.52. You know the hedge ratio, which is 0.25. You know the spot price today, which is 50, and you can solve for C. So let's make C the subject of the equation. It will be 0.25 into 50 and minus 9.52, and that is exactly what you see over here. 0.25 into 50 minus 9.52, and the value of the option today is 2.98. So it's actually a very simple process. It's just that you've got 1, 2, 3, 4, 5, 6 steps. So that's why it might feel a little bit complicated, but actually it is very simple. And this is the end of the second video. In the third video, we're going to get into risk neutral pricing, and that will be the last video for this learning module.